Hello and welcome to another video lesson with Mr. Roman. Today the lesson is going to be titled Inscribed Angles, and we're dealing with inscribed angles on a circle. So in your notes you see that it says name the central angle of the indicated arc. So here we have arc ACB, which I went ahead and labeled here with the red arc. So A to C to B is arc ACB. And then the central angle that's going along with that would be angle AQB. Okay, so remember, it has the same endpoints as the arc itself, except the Q here is the vertex of the angle, whereas C just tells you the where the arc's direction is going. So in letter B, we have arc TU, which I went ahead and highlighted in blue here, so arc TU. And then the central angle is going to be TQU that connects to those endpoints. And so here we put angle TQU. So an inscribed angle has its vertex on the circle and two chords as the legs. So notice here we have this circle. B is a vertex of angle ABC, and it's on the circle. So this vertex here is on the circle. And then the legs, which would be AB and BC, those are chords of this circle. And so this angle ABC would be considered an inscribed angle. And what we know about inscribed angles is that they are half the measure of the arc that intercepts them. So here, angle ABC intersects this arc AC. And so whatever the measurement of AC is, angle ABC is going to be half that measure. Another way you could look at it is you could look at it as angle ABC is twice as much, or I'm sorry, angle ABC times 2 is equal to the measure of arc AC. And then again, you could take the measure of arc AC and divide that by 2 to get angle ABC. So here's a practical example of what this means. So if we knew that arc AC was 50 degrees, well, then that would mean that angle ABC here would be 25 degrees. Example 1 says calculate the measure of the inscribed angle or the intercepted arc of the inscribed angle. So here we have, again, angle ABC is an inscribed angle because its vertex here is on the circle, and it has two chords as legs, so the chord BA and the chord BC. Now, arc AC here is 60 degrees, so that would mean that half that is going to be angle ABC. So let's go ahead and see that. Angle ABC is equal to 30 degrees. And then in letter B, we see that angle RST is equal to 53 degrees. Well, that would mean that the intersected arc, which is RT, has to be double that. So in this case, arc RT is 106 degrees. In letter C, here we see that angle GFH is 32 degrees. That means that the intersected arc here of GH is going to be double that. So it's going to be 64 degrees. And then in letter D, we see that angle KLM is 40 degrees. Therefore, the intersected arc of KM is going to be double that, which is 80 degrees. In example 2, these are a little bit tougher because there's multiple lines and chords inside the circle. And so here it's got this question mark, and I'm going to go ahead and highlight where that angle is so you can see it more clearly. So angle WYL, which is written here, I've highlighted in blue. So the arc that it intersects, I'm going to highlight in red. So the arc being WL, and that arc is 120 degrees. So that means that this inscribed angle that's intersecting this arc has to be half that. So we would expect it to be 60 degrees. Then in letter B, again, we're looking at this angle here where the question mark is. That's angle EXC. So I'm going to highlight that in blue. And then the arc that intersects is going to be shown in red here. So arc EDC. Now, the measurement of arc EDC is going to be the 122, which is really arc ED, and then plus 106, which is arc CD. So putting those two arcs together, we would get 228 degrees. But since this inscribed angle of EXC is half of the intersected arc, then we need to take 228 and divide that by 2 to get 114. So here we would say angle EXC is equal to 114 degrees. Number 3, it says solve for x. Now, here we're given a little bit of information, but we're given that 2x plus 134 is arc JL, and then the 120 degrees is arc KL. And so kind of with our deductive reasoning here, we can figure out that arc JK is going to be double of this 53 degrees since this is an inscribed angle. And I'm going to go ahead and highlight these in different colors. So we know the green arc here, JK, is 106. We know JL is 2x plus 134, and we know KL is 120. But we also know that all the arcs in a circle, they all should add up to 360 degrees. So I'm going to go ahead and write an equation to represent that. So the first arc in green plus the second arc in blue plus the third arc in red should all equal 360 degrees. Now, if I simplify this left side of the equation, 106 plus 134 plus 120, that's going to give me 360. Now, that's a coincidence that the 360 equals this 360 over here. That's not always going to be the case. Okay, so now to solve for x here, we subtract 360 from both sides, and then that leaves us with 2x equals 0. And then now we divide both sides by 2, and then that leaves us with x equal to 0. And so we solved for x in example A. In example B, we see here that our angle LKJ is 2x plus 90. So I'm going to go ahead and highlight that in blue. And then the intersected arc of this inscribed angle is going to be the arc LJ. And really, we should have another letter in here to indicate that arc. But we know that this is a semicircle. Okay, so the semicircle here is 180 degrees because it's half the circle, the full circle being 360 degrees. And we also know that the inscribed angle here of LKJ is half of the arc that it intersects. So here the arc is 180, so we know that this angle here has to be equal to 90 degrees. So we can set 2x plus 90 equal to 90, which I've shown here with the equation. Now again, this is a coincidence because 90 is equal to 90 here. But to solve this, you would subtract 90 from both sides, and then that would leave you with 2x equals 0, and then divide again by 2, and that gives you x equals 0. So we went ahead and solved for x in letter B. And that concludes our video lesson.